And we are live. Hello everyone, welcome to today's workshop. So, hello. Let's first start with a sound check. So there are 37 people now, and probably the number will increase a bit. So, hello Amar. I take it you are hearing us very well. Please confirm. Artyom, say something so we can... Okay, so, okay, all good. I think our friends there can hear us. So I think we can start. Okay, so let's see. Welcome to today's workshop by Data Stocks developers. This is Stefano, and maybe we can show our presenter slides. This is me, Stefano. I'm a developer advocate at Data Stocks, where I work extensively with Apache Cassandra, which is a distributed database that I like a lot. I like distributed systems. I like teaching, of course, and my background is originally in computational physics. I like Python, and this is for me. Now, Artyom, tell us a few words about you. Okay, Artyom, sorry, I think we have trouble hearing you on YouTube. That's pretty weird. That's very strange. So let's see. Try. Yeah, that should be good. That should be good. As far as I can see from here, that should be all good. It's pretty strange. Let's see. I can't see the reason why. Oh. You know, that's pretty weird. I see your signal coming here loud and clear here, and for some reason that does not go through. That's yeah, like debugging. That's a bit of a problem. And let's try switching. Okay, so I know what I might try to do. Okay, can you try again? That's very much, I don't think, oh, come on, that's really unfortunate. I don't know what I can do at this point. Yeah, exactly. Thank you, Cedric. This is a bit of a unexpected problem at this point. Let's see. Okay, so maybe I can do, I remember there was a trick to be tried here. Sorry guys for the delay. Artyom, can you try again?
Yeah, if you can hear me, please type in the chat, say something, say yes. Hello, can you hear me?
Okay.
Yes.
Okay, is the sound good enough? I did the rugs trick. Okay, that's very good. Hi, Saverio, nice to see you. Hi. Okay, so we can start again. Sorry, Artyom, I did the rugs trick. We will later debug it. Okay, a little soft, so maybe I can raise the volume a bit. Okay, so good, we can start again. Okay, you were saying?
Couldn't have done it without me anyway. So, but
Come on.
my background is in databases. I've been working with different types of databases for almost 20 years, with relational, with different types of NoSQL, with graph databases, with data warehousing as well, and analytics. Of course, maybe you've heard about Cassandra data modeling methodology. That's something that I created back in the day, and of course, Cassandra. I've been working with Cassandra for almost 10 years, so have a lot of experience there. Back to you, Stefan.
Okay, so back to us. Of course, today's workshop is, you see the two of us, but there is a whole team, and here is the whole team. In particular, in these days, most of the team you see here is around the world, because we are running a multi-location series of events called Cassandra Days. That's just a fun fact. So hi everyone, wherever in the world you are, Asia, US, whatever. And we can really start now. So today we are going to see, today's is a machine learning based workshop. We will have a quick look at what might be a use case for the stack we are going to describe. We are going to look at how a database, a NoSQL database, can be of help to real life application deployed that makes use of machine learning. Then we will go a bit more in detail on the AI part, how to train and how does this neural network works. The last very important step will be how to deploy and serve the trained model as an API, and that we will do using Python, as is probably customary for most machine learning folks out there. And at the end, we will conclude. But before we start, I will quickly go through a few pointers for today. So how to take the best of today's workshop. You are watching us live or maybe recorded on YouTube, of course. I say recorded because this I say immediately for everyone. This workshop is being recorded and will remain available on YouTube at the same link. So you can go back to it anytime. Of course, you see there is a chat on next to the video feed, and this is, you're welcome to interact, to ask questions and whatever. Even though, of course, when the live is over, the chat will be vanishing. So you are invited to join us on Discord. Maybe I can have, okay, I have to turn, okay, we will later give you the link. You can see it here, so maybe I can try to have it here. Okay, it takes for some reason some time to appear, but be patient. Please join us on Discord. We will give the link again by the end of the workshop for discussion that might go longer than the video, longer than the live, for any kind of discussion and help and support and whatever you want to discuss. This is not the end of the interactivity, because we also have games and quiz. In particular, by the end of the workshop, there will be a quiz with prizes, so get ready to win some swag. And that's most of it. Now, what tools will we use today? We will use, well, GitHub hosts code that we will run, instructions, a complete detailed README for all of you who want to do the exercise with or without us. So the README is also detailed enough to work as a self-service exercise walkthrough if you want. And it also contains this very slide deck you are seeing. We will use Gitpod as an IDE in the cloud. You will see it later. It's a pretty cool technology if you don't know it. And we will use ASTRA-DB, which is a database as a service in the cloud built by DataStax and built on Apache Cassandra. And that will work as a back-end storage layer for the API of today. I want to acknowledge and say thank you to Coding for Entrepreneurs, who are, well, the original creators of the content from which this one is built. So there is something more and something less in this version of the content, but the original idea goes back to them. So I suggest you to check their YouTube and blog, because there's more around this machine learning exercise. Something that I didn't say is that you don't need to ever leave your browser for the whole of today's exercise. You will do everything from the browser, and you will see how. Now, let's do a bit of interactive, well, it's not yet the quiz, but it's a bunch of questions to get to know our audience better. So maybe I can ask Menti to, I can ask Nightbot to please drop a link here, and I will go to this interactive presentation here. So something went wrong. Reload. That's awesome to see. Let's see. Okay. That seems to be back to normal. Oh, something went wrong. That's very awesome to see. Today we seem to have made the demo gods very angry, but bear with us. We will find a way. I don't know. Maybe I can just ignore this. Okay, let's try ignoring it. I see this something went wrong, but who cares? Okay. So let's see. Apparently that is okay. I see. Something very weird is happening. Errors. Oh, come on. Now this is a bit strange, of course. Demo. Okay. So don't mind the errors, of course. Please try to join with the link you see here in on screen. There is a QR code, and there is also in the chat. I see some of you have joined, are joining, 14 of you. So maybe we can start, and you can keep joining. So this is a platform for interactive. Okay, yeah, the link is working. This is a platform for interactive questions and answers. And we will use it later for the quiz. So please, once you connect, stay connected to the end. But now we are just asking you a few questions to know you better. So first point, where are you coming from? Where are you joining us from today? Let's see. I'm not sure this is working today. This is Mentimeter that is having some trouble.
We have some responses in the chat, but something with Mentimeter.
India, Italy, India, Miami, Angola, France, Brazil, California. That's great.
Yes.
It's great. Yeah. So Menti seems to be a bit strange, but yeah, Mentimeter is not working. But I think it started. Yeah. I think I started it, but it's behaving a bit weird today. Let's try again. No, I can hit this reload, but so maybe we can
skip it.
We can skip these questions. Sorry. Yeah, I can't read on the page. I'm not sure what's happening. I will try to debug Menti live, of course, during idle parts of today. Yeah, but I think I started it. I'm not sure where I should hit to, Okay, I will. Okay. Maybe. I don't think it's very responsive today. I mean, I know I have to start it, but that's really, there's something really weird going on, in my opinion, today with this, but it's very slow as far as I can see, but maybe I can just, I think Menti today, yeah. Come on. I see too many errors. We can skip this part, and I will try to, yeah, I cannot clone. Oh, maybe now I can, because it was too slow. Yeah, I think there are some backend errors at this point, but let's keep Menti for now. You see, there are all sorts of problems. Okay, let's go back to the slides. That's the meat. That's what we are here for, right? Okay, so let me switch to Artyom's screen for the second part, use case and technologies. It's yours.
Okay. So the second, we're going to talk what we will create today during the workshop. What's the goal of the project we'll be working on? And the goal is to create a system, to design its architecture, to implement it, and almost deploy to production. There will be a few other extra things that you may need for production, but it's going to be close. So this system will encapsulate a classifier and API. So it's text classifier. The clients will send us a text message, which could be coming from an SMS or could be a YouTube comment, or could be just an email. And our system will be able to tell whether it's spam or not spam. And it will do it with certain degree of confidence. So if we give a message, for example, if an email system receives a message for you, an email for you, it can use our system to decide whether this message is spam or not. If it's spam, the email system will place it in the spam folder. Otherwise, it will place it in inbox folder. So this is how it will work. And this system that we will be working on has two components. One of them is API, another one is the machine learning component. So let's talk about API first. The API will see the machine learning component as a black box. So it does have some functionality, but the API does not need to know how that functionality is implemented. So it simply needs to expose that functionality to the external world. So API is application programming interface. In our case, we're going to create web-based API. So there will be clients will be able to interact with this API using HTTP protocol. So it's like REST API type of thing. And the persona who is going to be creating the API is usually a software engineer who is concerned with taking this awesome black box and exposing it to external world, to clients, but doing it in a way that it's secure, reliable, it performs well, it scales well, and so on. And then there is a second component, which is ML component. So this one is created by machine learning engineer, by data scientist, and sometimes, so this component is usually always evolves because conditions change, algorithms improve. There is always room for experimentation to improve, like to improve the classifier, to improve other predictive models, and so on and so on. So this component can be a bit messy. The scientist's goal is to create model that does very well in terms of classification in our case, right? So it really classifies well. So the scientist measures performance not usually in terms of milliseconds, but in terms of how well it fits the data set, how well it classifies. So the main concern of the scientist will be science rather than performance and scalability, right? But there will be some of that as well. So in this workshop, we have two of those people, two of those personas working together on both components, and while they're clearly separate, the classifier and API, they need to work together, and this is our goal, to show you how they will work together. So we will design a system that has an architecture. So here we're actually introducing a third component. So the very minimum awesome is we have the model and we have API. But if you think about it, you will have so one of the things you will most likely have to do if you're running a system that serves thousands and maybe millions of requests, you will have to cache the response. So here we have the machine learning component that can take a little bit time to classify text in our case. So it may not give us a response as fast as we would like it to be, not in real time. Sometimes maybe it's going to be 25 milliseconds. Sometimes maybe it's going to be 100 milliseconds, depending on the model complexity and all of that. So scaling that, using caching to scale that to improve the performance will be great. So this is something that the engineer will take care of. So here we have the client sending us the text message and asking us to classify whether it's spam or not. The API will first look up this message in the database, and we'll see if the result for this exact message has already been computed. If this is the case, then the database will respond us within single-digit millisecond time, so it's going to be very quick, and the API will forward the result to the client with certain degree of confidence, of course, additional parameter. And then if that message is not in the cache, not in the database, then we will send the request to the model. It may take a little bit longer, but the computation will be done, and the response will be sent to API and will be stored into database as well. So think about it. The database is going to be here as a cache, and it's going to improve performance substantially. So we will work on all of those three parts in these workshops. We will create database. We will create the machine learning model based on neural networks, and we will create API. What kind of technologies we will use for that are shown here. So for a machine learning component, we're going to use Keras and TensorFlow. So Keras is a high-level API for working with creating models based on artificial neural networks, and TensorFlow is going to, the API is implemented in TensorFlow. TensorFlow is going to be a platform that we are going to run this type of the training and all the training, testing, preparation, all of that. So then for database, we're going to use ASTRA, which is a serverless database. What it means, it's going to scale for us automatically. So it's distributed database. It manages clusters with multiple nodes, multiple servers. But because it's serverless, we do not really need to manage anything. We don't know how many servers are there. If there are more requests, then automatically the database will auto-scale and add additional resources. If there are less requests, it will downscale, it will save you on those resources. So we will talk about this database a little bit more soon. The third component, API, we're going to use Python and FastAPI. FastAPI is a library that allows us to create modern APIs. And in our case, it's going to be a web API. And to run that web API, we will need to use a web server. So in this case, it's Ubicorn, and it will run the API. It will actually get the request. We'll forward those to API calls, and the API will use the model, will use the database, and at the end we will return the result. Okay, and this is the high-level overview of what we're going to do, and Stefano is going to talk about all of those different components in more details, and I will be showing you the hands-on how those components run, how they're implemented, and how they run.
Yes, very good. In the meantime, I have great news because I managed to map my Menti problem to a rotten cookie. I had to clear, log out, do a bit of cleanup, and I managed to get in again. And I have a new code, which you see in the chat and you can use to join. But okay, the initial questions, I kept them on a side. There is one, you can answer it, but we will have to keep Menti for the goodies at the end of the workshop. So take your time, but please make sure you join for later. Now maybe we can go to the slides, to the important bits, and I will switch to my screen, almost unnoticeable switch, but now it's mine. And we speak a bit of database. So as Artyom has well explained, and thank you, we want to enhance the power of our API with a cache layer and some another little thing that requires a persistence layer. So we not only want to expose a simple model with input, calculation, and output, but we want to enhance it with a cache to save some computation time. Suppose the model is very heavy, which is most times the case. And maybe we also want to offer some more features to our users, such as you will see in a moment. So first, let me introduce you to Cassandra. Artyom already did a good job at speaking about that, but Cassandra is a NoSQL distributed database that has a few very important properties that make it one of the best databases for a wide range of use cases. It is very good at handling big data, and big we mean petabytes. It is very fast at reading and writing. It is able to scale in a linear way. That means we want double throughput, and we just have to have double number of nodes, so no sublinearity. It is highly available. It is able to self-heal to some extent, very robust, resistant to nodes going down and connection problems, mostly in an automated way. And a Cassandra database not only is highly available, but it is also able to be spread over several continents, if you want, and also several cloud vendors. So you can have a database that is partially in Asia, partially in Europe, a bit on AWS, a bit on-premise, a bit on Azure, and so on. And on top of that, it is vendor independent because it is under the Apache license, so it is impossible that you will experience any kind of lock-in. And that's Cassandra in one slide. Of course, we are, as a company, are very much focused on Cassandra. And if you are more interested, today we are going to use it in a, let's say we're going to brush the surface of what Cassandra has to offer. But if you are interested in a very powerful NoSQL database, please join us. We might drop a link to our other workshops here in the chat. We have dedicated workshops to many of the features of Cassandra. And if you want to learn more, you are welcome to join us. Also on Discord, most of the discussion is about Cassandra, of course. Okay, so now let me go one step further. What DataStax does is it takes Cassandra and it builds and it repackages it as a service in the cloud. So as Artyom was saying, you will not have to deal with operations, scaling, servers. It will just be a service available for you in the cloud. And on top of it, it's not just Cassandra, but it is equipped with a streaming counterpart. That means event streaming or message, if you want, message platforms. And to access Cassandra, which now will be called ASTRA-DB, that's the cloud version, cloud product, there are several different ways to access it, several APIs, from GraphQL to document, think schemaless, REST API, gRPC, and also the good old SQL standard base language that Cassandra speaks, which incidentally is what we are going to use today. Okay, so that being said, let's go back to our needs for today. As Artyom was saying, we want to use a database, so a persistence layer to store and retrieve data. We want to use it in our API as a cache layer. So every time a request for a new detection, spam or not, arrives to the API, before starting the machine learning model, which might take CPU resources, we want to check if it's cached already. That's because there are two assumptions here. One is prediction is expensive. So running the AI model is expensive. The other is output is deterministic. So we can just we can be sure that if we run the model again on the same input, we will get the same output. And then in that case, why should we run the model if we can cache the answer already and serve it fast? In particular, if you think of an SMS spam classification, it's likely that messages will be sent to many parties. So they will be all checking the spam status of a same text. So having a cache in this case is particularly useful because it's likely that the same message will be asked to the API over and over. So we want to store a new prediction when it's not in the cache and get it when it's in the cache. That's not the only use for a database today, because we also want to keep a log of the previous calls to the API by a given user, by a given client. And we will identify clients by the IP the request comes from, for example. And so we want a different table to store every call that has happened, and maybe also offer the client an endpoint to retrieve the history of their calls. That's an example, of course, but on this feature you might think building a rate limiter or a pay-per-call model with a monthly billing, whatever you can imagine. So these are two sample usages of a database to enhance the power of your API. And we will integrate them in the API a bit later. Okay, so I mentioned two tables. That's because Cassandra is a database based on tables. And indeed, we will have two tables. You see them here. One is spam cache items for storing basically association between text and spam status, spam, not spam, or a bit more indeed. And the other table is the log of the calls per caller. So these two tables have a few columns. You see them here. And okay, we are not going too much in detail, but you see some of the columns are marked with a capital K, like model version and input. Or in the second table, we have caller ID, which would be an IP address of the caller. Called hour is in integer hour, the call to the API came. And we also have called at, which is a full timestamp, and it is marked with a C. Now, what are these symbols? Of course, it's a bit of a pity that today we cannot devote 5 or 6 hours to data modeling with Cassandra, which is a fascinating topic in itself. And I think Artyom here is one of the most knowledgeable person on how to model data with Cassandra you can ever meet. That's why it's really a pity, but we offer dedicated courses on how to model data with Cassandra. For now, I will just try to pique your interest with these. You see now the purple block contains caller ID, called hour, and called at. That is to mean that these three columns form the primary key. So every different row in this table has different values for these three fields. That's uniqueness, as in many databases. But that's not the end of the story, because we also have a subset of these, the first two, and that's the partition key. What does that mean? It means that you remember that Cassandra is a database distributed over several nodes. Well, how are data distributed? Well, every row in this table with the same value for caller ID and called hour is guaranteed to be next to the other. So this will be a way of grouping rows and partitioning the table across nodes, but keeping some rows guaranteed to be together on the same machine. That means that we can retrieve them all at once fast. And that's the biggest secret of how Cassandra achieves high performance while being a distributed database. And that's what is called the partition key. In particular, in this case, we want to offer the caller the log of all invocations to the API done in the last hour, for example. And that's the way to keep all such rows grouped together and have to query a single node in the database, even though the database is spread over several nodes. Okay, so I see there is a question about dropping the table when there is a cache. Yes, of course, if you do disruptive changes to the table, to the cache table, that's going to be a disruption to the user. But remember, this is a cache. So in the worst case, the user will have to wait a few seconds, even though the item used to be cached. So depending on your use case, you might go great lengths in ensuring you have no downtime, no unavailability of data. But that goes a bit beyond the scope of today. But well, in a cache, maybe Cedric, if he's still around, might try to answer these. But now you will excuse me if we go forward with today's main focus. Remember, in this case, it's a cache. So even if it gets cleared, no big loss, just a bit of performance loss. Okay, sorry.
So I would add that we're using database as a cache, and the first table there is really the cache table. The second table is a log, right? And you can think about the first table is as key value table, where we have composite key consisting of model version and input, and we have structured value, but essentially we have key value pairs there. So it's like a key value database you can think about. But the second table is the log, which stores data ordered by timestamp. That time UID actually component of a timestamp will be used for ordering. So this table represents time series that we store. But yeah, if we drop a table, yeah, we lose data. We basically, if we drop the first table, we basically nullify our cache, and then we will create new table. We'll start from scratch with cache.
Yes. Of course, if you have to change the schema, it really depends on your use case. If you are adding a row, a column, that's not a problem. If you are doing something more complex, you might start thinking about a full-fledged migration or to invent some specific workaround. But again, that's a bit beyond today's scope. Maybe we can get in touch later on Discord to discuss. Maybe you have a use case in mind in particular, Serge. But now I will go forward. So I mentioned that Cassandra, in particular AstraDB, can be accessed in various ways. There are various APIs to speak to Cassandra. The most fundamental one, if you want, is CQL, which is the Cassandra query language. No problem. We always welcome questions, of course. In particular, today we are going to use the Python drivers, the vanilla drivers to access Cassandra through CQL language. But the drivers of Cassandra in particular, Python as well as many other, offer object mapper facility. So instead of running queries, today we are going to use an object mapper. If you are used to ORM access to databases in your code, then you just have to remove the R because Cassandra is not relational. So you just have an object mapper. But the principle is very similar. You see in the left panel, we define a Python class with some special fields and some members. And this will be automatically mapped to a table. And this table will be created for you once with this sync table directive in the initialization step you see in the second block. And then in the two blocks on the right, you see how to create a new row through methods of this object, and how to do queries, how to search for items, again, using these filter methods of this object, which is just looks like a very Pythonic Python object. So this is one of the ways. It's not the only one, but this is what you will see as you dive into the code, which you are invited to do even more than we can afford in the time of this workshop. It's all there for you to experiment with. I think, Artyom, it's time for the first part of the hands-on. So everyone out there, warm your fingers, and you can start by creating your database and your token, I think. So I would say back to you. There. I'm not hearing you, Artyom.
Okay, yes, I'm back. So
okay.
In the chat, you will find the link to GitHub, and you will get to this page, which is the repo with everything that we need. And
I will just make our ourselves a bit smaller to leave more room for the demo. Sorry, you're good to go.
Sure. So there is a lot of useful information here, and I will have to be skipping the. If you're gonna do it again on your own, there are a lot of additional information of how things done and why they are done this way. But I will move directly to the what we need to do. So for this first part, we will create a database, and it's a cloud. The AstraDB is a cloud service. It's a database service in the cloud. So we will be using interface to just specify what we need to create. We will create database with name workshops and key space spam classifier. Okay, so this is the link. I will open it in new tab. And in my case, so if you never used AstraDB before, it's free. You get credit. You don't need to specify credit card or anything like that. You get $25 credit. That's enough to store like 80 gigabytes of data and do millions of operations, reads and writes. And we are not going to do that much in these workshops, so this should be safe. So if you never use, then you can sign up. In my case, I already used it before, so I will sign in with Google, with my Google account. Okay. And I will see the UI, which will allow me to create the database. In my case, I'm going to switch the organization, specifically going to use one for workshops, and it has no databases right now. So databases here, there are no databases created. There is some usage because we use a previous database and now we terminated it. But in your case, if you have an existing database called workshops, the only thing you may need to do is if it's hibernated, if you attended our workshop before and didn't use that database a while, then it may be hibernated, so you can click on this Uminate. In my case, I don't have databases, and you may not have any databases, so I will create serverless database. Again, serverless, and I'm not gonna specify how many servers I need, and things like that. Like many other databases that supposedly auto scale, they will still ask you to specify a minimum number of instances, my maximum number of instances. That's not the case here. So workshops is the name of the database, and the name of the key space is spam classifier. Okay. What else do we need to choose? Well, we need to choose the where we will run the database, and there are three options. Since I'm using free account and you using free account, then we are going to use Google Cloud. So some of the for free accounts, many of those providers and regions are disabled. So let's choose Google Cloud, North America, and there's only one region here that is available for free accounts. And I'm going to, after that, I'm going to just click create database. And it can take a few minutes to create the database, to initialize those servers and have them fully functional.
Yeah. So in the meantime, please everyone create your database. That means go to the link we give in the chat. That's also in the repo, and create the database as Artyom shown. So the name of the database should be workshops, and the key space should be spam classifier. No spaces, no dash. If you keep the name as we show, everything downstream is easier because most commands there are tailored to these choices. So don't be creative here, please, for your good. So maybe while I would like to ask you to give me a thumbs up in the chat if you manage to have this screen database created. So while the database is being provisioned, please give me a thumbs up. The link is not working. You mean Astra Dev? Okay, that's all good, Saverio. That's good. That's strange because I see the link working on my. Okay, so Cesare, you might try to go to.
You can go to astra.datastacks.com. So
and then just sign up. Yeah, you can try to go astradatastax.com and just sign up for a new account. It's weird that it doesn't work for you, but maybe just okay. Sorry, Artyom, back to you. I see some thumbs up.
Yeah, the database in my case, your database is now active. I didn't have to wait for this message. I could just click on go to databases and wait there, but essentially you will see the, so right now I'm under the database workshops, it's active, and it has key space spam classifier. So database can have many key spaces, and key spaces is like one single app. You can think about it as it serves one single application, stores data for one application. So it's possible to create additional key spaces to for needs of other applications. So now what you can do, so go back to dashboard. So the second step of this exercise is to create a token. So we created a database, it's empty, it doesn't have tables. We will create the tables programmatically. It doesn't have any data, but it has a name, it has key space that will be able to store data. And now in your dashboard, you have this one active database. Again, in case you already have workshops before, and just make sure it's active, it's not hibernated. If it's hibernated, you will need to resume it. So the second step, we will be accessing this database from Python code. And for that, we will need to be able to somehow authenticate and get some permissions to use this database from an external application. So we will create so-called token, generate a token. So this is something, again, this is how I got there. There are the menu 3 dots here next to the database. And this page is the dashboard. I can click generate a token. And here, I will have the interface to select which role I would like to use. In our case, we want to be database administrators because we will be creating tables, we'll be inserting data, we'll be creating data. So database administrator, and then you can click on generate token. So the token that we're generating is just a string of letters and numbers, and it's a secret string. So it's something that you should not share with anyone else, because with that token, somebody can access your database. In my case, I'm using this sandbox account for workshops. So I will show you the token so you can see what it is, but I will delete it afterwards. And again, the token will only be shown once. So you want to copy it somewhere so we can use it later when we create an application. So generate token, and there's a bunch of, there are a couple of other things, not a bunch, right? There's a client ID, client secret. This is used, so different values can be used for different ways to access database, because there are drivers, there are gRPC, there is REST API, and a few others. So different methods will use different authentication approaches. So in our case, we only need token. This is the last one. It starts with ASTRA CS. So you can copy it and save it somewhere else. Okay, because once I close this, okay, so this is my client ID. This is the record of that token generation, but the only thing I can do is delete it. I cannot see that token again. Okay. So just make sure you have the token somewhere in a different file, or later we can generate another token. That should not be a huge problem. And that's the end of this very simple exercise where we created a database and the token to access it later.
Okay, great. So maybe we can wait 1 minute or so to give everyone time to generate the token. Please write in the chat if you have trouble getting to the point where you have your token. I will switch to my monitor now, but maybe I will also switch to us being bigger again. Hello. Okay, so Okay, Marius, no idea where this token is. Okay, so
Yeah,
maybe
I see the message.
maybe
So,
Artyom, I can switch back to you just to show where to go. The point is to create a token that will be later used by code, by command line programs. This is your screen again. It will be used to access ASTRA from code. So
yeah, I think I will show again when we need to use that token later,
okay,
add it to the application. I will show it again. I will show again right now. It's pretty easy. So again, dashboards, once you create a database, click on the dashboard and you will see this database that you created here under active databases. All you need to do to generate the token is to click on the menu here and select generate a token.
yeah,
You will get to this screen, token management, okay, and you will select role, which will be assigned to that token. So I want
okay,
that token to have the permissions of database administrator. You will click generate token, and your token is the last value here. So you will copy it and keep it somewhere safe until we need to use it for the application. Okay.
okay. So I think I see got it. So great. Now I will reappear. I temporarily disappear and I will go back to my screen again. Okay, so let's speak a bit about AI before we run the code that trains the model and prepares the data, or actually prepares the data and trains the model. We don't have so much time, so I will go quickly through it just to throw a bit of introduction and ideas around for anybody for later deeper investigation, deeper study. But in this spirit, let me tell you one thing. This section is not like a comprehensive compendium that will make you an expert on AI. Of course, there's no time, and that's not the scope of today. We are not going to bury you behind stacks of linear algebra or mathematics or anything. By the way, bonus points for anyone who recognizes the guy in the picture. Write in the chat if you know, but I will go forward. So this is not mathematics. Today is not mathematics and a lot of machine learning. It's just an initial introduction. Okay, so let me go to the point. My introduction, yes, Saverio, well done. Richard Feynman, Nobel Prize in Physics. Woohoo! Well done, Saverio. Okay, one of my favorite physicists for his brains and his guts. Okay, so back to us. Today's goal for me is to make you able to understand what we mean by sentences such as ML, LSTM, RNN for NLP. All clear, right? So there is a bit of lingo and a bit of concept behind this. So what is machine learning? Machine learning in general is a set of algorithms. Yeah, yes, I agree. A set of algorithms that improve by eating data and getting better without being explicitly programmed for the task they have to solve. Basically, it's statistical inference, a very specialized form of statistical inference. There is a lot of mathematics behind and whatnot. But the good news is that today, these machine learning tools are easy to use, I would say, without the need to know everything that goes on in the belly of this machinery. Actually, you probably have been doing machine learning already, even if you just had done a least square fit or a logistic regression. That's already machine learning, right? You have points, data points that make your model better. That's basically the principle. But of course, machine learning usually means something more convoluted, more complicated than, let's say, a quadratic fit. And the basic idea, and this is in the hands of this mad scientist persona, the basic idea is that a model is chosen some geometry, some architecture of a model, some general mathematical formulation of the model is chosen. And it is a blank slate. It doesn't know yet the problem it has to solve. It just has a shape. Then something called training happens, which is tuning of the many parameters in the model. And you end up with a model that is ready to run and to give prediction on new pieces of input. So what I just described is, in particular, is the so-called supervised learning, which means we know what the model has to find out. So we can train the model by providing not only input data points, a set of input data, but also a corresponding set of labels. In this case, we have a list of texts and a corresponding list of whether each one is spam or not. So this is training data and labels. So this is a labeled training data. So training means basically tuning the parameters of the model so that the model is able to give predictions, to give new assessments over new data points that are satisfactory. And basically training is the operation that seeks to make the results of the model as similar as possible to the input labels for a set of known results. So training means we want the model to mimic as closely as possible this Y column of results that we happen to know. Okay, so that's supervised learning. Now, there are many algorithms in machine learning, so many that you cannot even name it in one slide. We will focus on neural networks, which are pretty famous, and they are more or less modeled about some ideas on how the human brain works. So a neural network is a simulation in the computer of a set of neurons, of artificial neurons, which are units that receive signal, apply a very simple rule, and might or not emit an outward signal to other neurons. So you see there's a schematic image here. There are 3 neurons playing the role of input, and probably the input, whatever, maybe the sentence, will be encoded somehow in these neurons. They will, according to some rules, they will emit some signal to other neurons and so on and so forth until the point where the output neurons have some values as output, and we will be able to read this output and get back our final result. So this is a big machine for statistical inference structured as this complex network of points, eating signal, doing some basic processing, and spitting out some more signal. Every single neuron is very simple in general. It just has a few numbers to be tuned. These are the ones in purple here on the right. The intelligence of the machine learning is not in any individual neuron, which is pretty simple, but it is in the whole network and in the choice of the weights of these numbers in purple. Okay, so actually I lied, because what you saw here in this picture is a very simple, if you want, neural network. It is a set of layers. As you see here, the first picture here is made by a set of layers, and this is what is called a feed-forward network, meaning that the signal flows in a specific direction and nothing else. So it's like a dish of lasagna, more or less. But you can make things more interesting if you start having signal that goes back and rewinds in a loop over the network. And that is what is called a recurrent neural network. And once you have these feedback loops in the signal propagation in the network, a whole new level of understanding, if you want, occurs in the network. And that's more like a dish of spaghetti or tagliatelle, as you see in the second picture, because you have a messy situation that actually makes the practical handling of these networks a bit more complicated. Training is more, let's say, is harder for many reasons. But the cool thing is that once you have arrows that go back and form loops, you start having memory in your network. So in the understanding of whatever the input is, your network starts to be able to remember things as it processes your signal. So if you have sequences as input, such as a sentence or a sound or a voice, whatever, these are the right networks to use. And I'm sorry, but for reasons of time, we will skip some of the details, but the probably most successful recurrent network is called LSTM, which stands for long short-term memory. It's a technical trick, if you want, to overcome some technical problems in training by explicit introduction of memory elements. You are able to retain memory while keeping training feasible. And this is the network we are going to use. So there is recurrent network, but limited to particular structures. So it's not the most general network you can have, which is hard to train, next to impossible. Okay, so that was a very brief introduction to recurrent neural networks, I reckon, but let's move forward to NLP, or natural language processing. Well, that's a very important and big field in machine learning, and it deals with understanding and treating and processing language made by humans, such as an email, a book, a text, a post, a tweet, whatever. Well, that's a very old and established field in machine learning. So being able to extract meaning and value from text is a very important topic, because a lot of data out there in the world is in the form of text. So being able to extract whatever information it contains in an automated way has a very high value. And there are a lot of tasks, from translations, automated translation, sentiment analysis, auto-completion. You probably interact with these kind of tasks probably on a daily basis with your smartphone and whatnot. And this is where LSTM really shines. So because texts are naturally sequences, and these are the kind of networks that are best to deal with those. Now, NLP is a evolving field. There are astonishing new developments every year. You remember, maybe you have heard of Word2Vec, then transformers such as BERT came out, and maybe you remember something called GPT-3, which was a breakthrough. It was able to write books or something like that. These are very huge models with hundreds of billions of parameters, just to give you an idea. Training them takes a huge effort. Then recently, a whole swarm of so-called foundation models came out, which are general models which can then be adapted to subtasks with a very smaller effort. And that's more or less the situation. So today we're going to use an LSTM to do natural language processing, in particular classification of text. What do we mean by classification? Well, we spoke about that already a lot, but we actually have to do some preliminary transformation of the input to feed it to the network. So let's say we have the network trained and working. It actually eats numbers and spits numbers. So we need to do something else before that, because our input as humans is a sentence such as this: you want a free washing machine. So first, we need to make it into a list of numbers. And we do that with a tokenizer, which is a machine, so a function that transforms the input string into a list of integers, in our case, of fixed length. So we pad it with zeros to have a standard kind of input to the network. And we preliminary train the tokenizer to just be able to identify every word in the input text with a number. So the input then is a set of numbers, which is the language the neural network speaks. And then in the belly of the network, some processing happens thanks to these signals and weights and all of that. The final layer will spit out two numbers, two floating points between 0 and 1, and we will interpret them as probabilities of spam or not spam. Easy. Which means that we have to prepare the data set, because we have strings, text, and we need to make both the training data and the training labels into numbers. In particular, for training labels, we will not have a single column with 0, 1, like spam, not spam, but we will have the one-hot encoding, which works best. And then that means we have a column for spam, which is 0, 1, and a column for ham, or not spam, which will be 1 or 0, as you see here in the picture. The most important thing we do here is, here on the right, there will be more on that later, we split the input label dataset in two parts. We split in a training part and a testing part, and we will be very careful in keeping them separate. The reasons will be given later. Okay, so that's it. Artyom, I think it's back to you for the second part of the hands-on, where you will prepare the dataset for training, as I just shown, run the actual training of the model, and maybe run a quick test of the model after it has been trained and stored safely to a file.
Yes.
Just one thing, the training takes a few minutes because it's a complicated process, and during those minutes I will jump back to slides and quickly show something about training, so we use our time in the best way. Okay, so Artyom, I think it's back to you.
Yes. So we are going back to the GitHub repo, and in README file, so we just created the database. Now we will be able to do the data set preparation, training, and testing. Okay. So we will do it with, so we need an environment to do that, right? Not on your local machine, laptop, and things like that. So we will use Gitpod for that. So here's the open in Gitpod button. So open it in the new tab. And here we will have essentially this repo that you saw in GitHub will be used in this workspace in Gitpod. So it may take a little bit time to initialize. Okay. So in my case, to use Gitpod, you will need to log in essentially, and for that you will use your GitHub account. And I'm using GitHub account, so I already signed in, so I was able to get there. So here, hopefully you were able to open this as well, the Gitpod. Let us know in the chat if you have an issue, but signing in is usually with GitHub, and you probably have GitHub account already. Okay, and again, this is a free environment that we can use to experiment, in our case, to build the model, train the model. So here we have Gitpod release notes. I will close them. We don't need to see them. And here in this area, we have the README file. So you can use your instructions here. However, they display it a little bit differently, which I will probably switch to regular instructions that we have in GitHub. Okay, but yeah, that's where we open the Gitpod here. We also have the file explorer with all the files that we will need. That's essentially the clone of the GitHub repo that you already seen. And we have terminals here. There are 3 different terminals. There is work one. There is so we will do most of the things here. There is one with for curl commands. So it's when we test our API, for example, we will use it. And there is one which is running a Jupyter notebook, and we will probably, so it's already running there, and that it may give you an error, but that's just the dependency. That is not important. So we may use Jupyter notebook, but just for the sake of saving time, we probably will not. So what do we have here in terms of files? Let me make it a little bit larger. Okay. So the training, under this training folder here, we have data set. Okay, you can open it and see the CSV file. There are 3 different columns: label, text, and source. So label is whether it's spam or not spam, spam or ham, and then the text itself. And then there is a source where this data set is coming. So there are 2 data sets merged here. One is SMS data set. The other one, if you scroll down, you will find that it's a YouTube spam data set. And Stefan is going to talk probably where they come from, and it's also information. You have links to those data sets. So those data sets were merged into one. Okay, so this is how our data set looks like. There is also prepared data set, which right now there is nothing but README that says once we take that original data set, we run the script, we will get a new data set. Then once we train the model itself will be placed in this train model version 1 folder. Okay, so that's where you will find them. Now, for this hands-on, we need to train the model. And training the model, before we train, we need to prepare a data set. Okay, we need to prepare a data set. We need to train the model, and we need to evaluate or test the model. So the first thing, preparing data set, we can do it with this script, or we can do it with Jupyter Notebook. So in case of Jupyter Notebook, you will have to open it in a new window. Let me show you how to do it, just in case if you like Jupyter Notebooks or you want to go back to it later.
You know, the choice between Jupyter and scripts is a bit of a constant source of fights within Python people, but I'm glad that today, despite the Menti problems, I managed to get a few outputs over the question whether Jupyter or scripts, and I'm glad to see that most of the answers were to each each task the right tool. That's great. Usually people get a bit religious about this, but it's nice to see reason tramples.
Yeah. So the Jupyter, the password here is spam classified, the same as the name of the key space. And under notebooks, you will find the prepare data set notebook. And then you will be able to run it, each cell separately. So I think it's great for learning purposes, because you can execute something, you can execute a block of code, and then you can uncomment and actually see what are those variables, what kind of values they got, right? So you will see that how the tokenizer tokenized your text, converted it to numbers, how the padding happened, and all of that, right? The danger, however, if you forget to run one of those cells, you will screw up things, and at the end, your prepared data set may not be correct. So I'm not going to run the cells in Jupyter Notebook. Instead, I will go back to our project here in GitHub, and I will simply use this prepare dataset, which contains that same code that you saw in the Jupyter Notebook, and I will execute it. So the instruction to execute it is here. So Python prepare dataset.py -v. So purpose output. Okay, I will go again. We are in the work terminal. Okay, and I'm gonna start it. So what will happen? All those the tokenizer is probably the main thing that we will still need to use later to make sense of the to be able to encode the new text messages that are coming from our clients, right? So we'll have to use the same tokenizer for the model to work. So it finished, tokenizer, padding, all of that. You can look at the prepared data set. So it's the pickle file format, it's binary, so there is not much for us to see. But so later when we train the model, we will actually be able to see tokenizer as JSON file. Okay, so the next step, so we prepared our data set. The next step would be to train it. And again, I will start the script because it can take several minutes, maybe 5, maybe 10 in some cases. So this is Python train model Py. And I'm going to start this script, and it will create new model under this trained model, but it will take some time. So if Stefano, you want to?
Yeah, of course. So just make sure that all of you also launch the train script, which just to make sure I also paste in the chat. So train the model with this command, python train model.py. That's pretty easy. It will take 5 to 10 minutes maybe. There is a question by Saverio. Why are we serializing with pickle? Okay, so, well, that's a good question, because I think the untold part of the question is, why on earth would you use pickle? And that's a good question, because pickle is not good for long-term storage, interoperability. It's not that you should never use pickle, but you use pickle only when your own program very quickly is storing and then reading, because everything else, pickle changes version, might be a bit tricky to read even just from a different version of Python. I remember very big trouble trying to read pickle files stored with Python 3 back with Python 2. So writing with Python 3 and reading them back with Python 2 is a hell, of course. Python is not meant for interoperability. So the reason here is that between transforming the data and using them for training, in our idea, it was a single persona doing some experimenting with a quick way to serialize data. And well, I think I'm not sure if every part of what we are storing here is easily serialized with JSON or other friendly formats. It's there's a bit,
maybe, but it's going to be slower, right? We want to use some binary format just for efficiency and efficiency in terms of being able to read it fast later, and also it's going to be a smaller data set. But it could be other formats.
Yeah, it's tricky because, and it's true. It's a binary way. It's a binary format and everything, and it's going to be read immediately after by the training process, probably, or let's say in the same experimentation by the same crazy scientist kind of person. But as soon as we get the trained model, if you look at what happens at the end of the training code, it will be written not with pickle, but with specific facilities offered by TensorFlow that make it possible to store a model in a long-term way, so that the API, any future version of the API, will be able to read it, load it in memory, and play it, basically run predictions with that. So you should avoid pickle for long-term stuff. Okay.
And for our purposes, I think we should switch to human readable format, so we can actually show, okay, this is CSV file we had, and this is a new file that we have. Will be useful for learning purposes. Yeah.
Yes, good point. Okay, so let me quickly, while we wait for the training to finish, show a few points. Well, this is a part, you see here a few lines of code that use the Keras sequential API, very Pythonic, and built on, in this case, using TensorFlow as backend to build the architecture of the network. So I'm not sure there is time to go much in details. You can later look at the slides, but the point is that this is not the most general network. As I mentioned, it's almost a lasagna, except one layer is a bit of spaghetti, just all mingled together. That's, let's say, a compromise between efficiency in training and we need this memory thing, this recurrence which is anyway confined to a single layer. So it's not loops everywhere. So the first layers encode the input numbers into a neural network friendly format, let's say into a vector. And then there is dropout, which maybe we'll mention quickly in a second. And then there is this LSTM layer. And at the end, there is this dense layer. So we are building the network architecture layers, layer by layer. The final layer condenses everything that is going on in the network into these two numbers, normalized to sum to 1. And this is this softmax activation function. The last line compiles the model, basically actually creates the network after we defined it line by line, layer by layer. Okay, so this is it for building the network. Now, again, training. I will probably just take 1 or 2 minutes on this. So training, I said a few times what training is. Training is tuning the parameters, the very many parameters in all neurons of the network in the particular way that predictions are very close as possible to the labeled input. And this is done by defining something called a loss function, which is a numerical, a quantitative way to define how close a set of labels is to another one. And the smaller this function is, the closer they are. So we want a way to move around the parameters until we get to this darker red point, let's say, to the minimum of this function. That's, of course, just a sketch because it's not, the parameters are not a one-dimensional axis. It's more like, in our network, it's like 300,000 parameters. So moving them around is not like walking down a slide, but it's more like walking in a mountain with hills and steeps and cliffs and whatever in the fog. You don't see anything except really just a few meters around you. So how do you do that? It's numerically, let's say computationally, it's not easy. And there are specific advanced techniques to do that in a computational, so with a computer, which are different than just taking, pencil and paper and calculating derivatives. So your best friend here is the stochastic gradient descent algorithm, which applies a bit of randomness to calculate where to go in a bit of a randomized way, using only subset of the input data to make computation a bit lightweight. This is one point. The other important input is backpropagation, which is, well, the chain rule for derivatives applied to how the neurons speak to each other. Because remember that you are trying to move around the parameters, the weights, and not the input values. So you need to find the best choice of parameters that make this loss function minimal, and you measure the loss function over a set of input labels. So these are the ingredients of the practical way of how, parameters are, Mario's parameters are mostly weights. In the case of this network, there is something more. Well, there is always also a threshold in the activation function, some horizontal threshold in where the step of the activation function occurs. But in this kind of network, there is also something more. There are a few parameters in the memory cell of the LSTM. So in general, parameters is a broader term. Most of the times it's weights and thresholds, but it might be more. So the last ingredient is dropout, which is a random way to, you switch off parts of the network and let them be dormant for some times in the training at random to avoid concentrating the knowledge in specific parts of the network, which would be then a fragile architecture should this part be somehow routed out of the signal pathways, so to speak. Okay, so we are back to why did we split training and testing data set? So we took this a few thousand input text, and some of them we don't use for training and we just use for testing, or should I say validating. That's because training will be done only with the training part, and the network will be better and better at guessing the spam status of this input. But the risk is that at some point, the network will stop learning what spam means and will just learn to mimic that very data set. And as soon as you give it a different text, it will maybe not even be so well behaving. So it's important that you keep some rows, let's say 1/3 or something like that. You keep some rows separate, and you never feed these input labels to the training and use that just independently to validate the model after the training has occurred. So you see in this left plot, you see what happens in a healthy situation. The red line is the value of the loss function as evaluated over the train set. And then from time to time, independently, I run the model on the test set and I see, okay, it's getting better and better. But look at the right side plot. At some point, I will see the training measurements get better and better, which means lower and lower, but the test set will go up. That means the model has started to learn how to reproduce that very set of input, and it's not anymore. It's not good at solving the general problem of identifying spam, and that is detected by feeding the test values, the test label set to the model, and you will notice that the model actually is worsening its accuracy, and then it's time to stop in the training. Well, if you want to go beyond that, you should also introduce a third set to keep testing and validation separate, but okay, let's move forward. That was just the basic idea. Artyom, how is your training going? And also the folks out there, is your training still running? Maybe someone can start giving a thumbs up if they get to the end of the training with the final result. By the way, the value of this loss function will be printed. Okay, finished. So
yeah,
Artyom also, okay, finished the training. Okay, done for many of you. Okay, so
we can test.
yes, so I will switch back to you for just a quick test, because as I mentioned, okay, so you should have the same screen that you are seeing now in Artyom monitor. So training finished. You see these saving lines. The model has been stored to a file, ready to be later used by the API.
Yes, so we have this trained model, and what we have here, we have JSON file for some metadata. We have a JSON file for spam tokenizer, which is basically maps text or words to integers, right? Update 27 from 380, and so on and so on, right? Even the number 100 is mapped to a number certain in this case. Interesting, right? So, but the model itself is again the binary file, the extension H5. So I think the reason this one was selected because it's it's supported by Keras as a more or less standard.
Yeah.
And then if you look at the train, so what happened? What happened there was training. Essentially, this is what Stefano was talking about. This is the model, right? This sequential model and LSTM where it's used, and the training is essentially just one call here with some parameters. Just feed that model into or feed that model into that data set that we have, right? And now we have a separate, well, we don't have a separate, and now we can test our data set, our model with some sample text messages, or that's text messages that you can actually create your own text message. So again, the instructions here: test the train model, and we have the Python script load test model that has a couple of tags that will allow you to see how it works, and then you can also specify your own tags if you want to. So here I'm going to, again, in the work terminal. I'm going to run this load test model.
Yeah, so this is just loading the stored model saved to a file after training, as the API code will do, just to test that it is possible to load it from file, run it on a test, and get predictions. So that's nothing more.
Yeah, and this is the first example. This is a nice touch, blah, 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 thank you so much. And it predicts that this is ham, with confidence around 66%. So it could be spam, actually. It's not high enough confidence, probably. But then for the second one, click here to win a free iPhone, and it predicts 93% confident that this is a spam.
So,
okay? And you can,
sorry, just a point. If you run this command, you will see probably slightly different numbers for the same input text. Can you guess why is it so? So you will see slightly different numbers than Artyom is showing for the same input text on the same model trained with the same code. Why?
so there is a non-deterministic component there.
Yes, well done, Sergey. Yes, the stochastic training introduces some non-determinism in the process. Yes, exactly. So by guessing the gradient and improving the weights, some randomness is introduced. Yeah, great, thank you. Okay, sorry. Go ahead, Artyom, sorry.
Yeah, no problem. That's a very good question. So another example, we pass in custom text message, and we're going to see the result. But this is pretty much this is something that we have the model, it works, and now we have to expose it to external world, to external clients. Okay, they should not be calling our Python scripts. They should be calling API, right? They should be much friendlier than just the model that can be loaded as a library and things like that. And again, you can look at the load test model, how it works, the code. It's not that complicated, just that model is loaded and then it's basically applied. The prediction is used. Okay, and
okay.
And that's it. We can talk about the API part now, and we have the last hands-on on exposing this model as an API.
Okay, so back to me for the API part, and there we go. Full screen, sorry. Yes. Okay, so we have a model stored as a set of files, and we have code that is able to read it and just subject text to it by doing all of the transformation, applying and reading back the results. Ready. Okay, so now what we do, we need to put that in production, which is the MLOps part of today's, right? And bring to production is by far not the easiest part. So real production deployments of AI is notoriously difficult. It involves a lot of challenges, especially because compared to the typical DevOps kind of approach, this is a bit more like a constant improvement cycle, because models get changed and then they go to production and then they have to be retrained, and then you have to deal with versioning all the time, and you have to make sure version input label data set matches the version of the model you're running, because otherwise you start having skew, and it's a mess. And there is a whole field called MLOps here that has sprung around such problems, bringing AI models to production. Oh, let me switch to the big heads here. There we go. Okay. So now we are at the point where the mad scientist has a black box, hands it over to the engineer who loves API, and he's a very serious person, doesn't want to get their hands into the box. They just want to build the architecture we saw already around it. We already saw the architecture stack, so let's move forward. We are speaking Python. You see here the structure of the project. And this is a FastAPI project. And well, we took care of splitting various functions to different models in the file structure to make the example clearer, even though most of these files are very small. I will spend a couple of minutes showing you around. So there is a main module that, besides running some initialization, it defines the FastAPI app object, and it will wire routes to it. This main module uses makes use of Pydantic. Pydantic is a data structure validation and marshalling library that comes naturally with FastAPI, and that's very handy because it helps us validating and marshalling input payloads and query parameters, and also to the same for output bodies of the HTTP request. Then there is a whole set of modules dealing with database access. Remember, we had a table for cache, a table for the call logs. So there is a module to abstract operations of reading rows and storing rows, which in turn relies on the object mapper classes we saw earlier. There is a separate module actually establishing the database connection to ASTRA-DB or to whatever, Cassandra in some cases, and that will make use of the secrets, a token, and so on. And then, of course, there is the most important part, the AI part, which is the model that has been trained and stored to a file. But before just slapping it, grafting it to the API, we will wrap it with a class, a general purpose class, which on one side, on the inside, reads the files with the model, but on the outside, it conforms to a standard set of methods. So basically, it's an interface which standardizes access to the prediction facilities of that very model. Why do we do that? Well, we do that so to handle versioning easily in the future. So let's say tomorrow the mad scientist comes up with a V2 of the model. We probably want to reuse most of this production API code. To do that, we will probably have a second black box with a second AI model, but they will probably be instances, let's say subclasses of the same interface, Python, so same class, with the same methods, with the same signature, so that the API will just be able to build a second set of routes, V1, V2, predict, whatever, and they will just be wired to the same API, maybe to coexist at the same time, as is usually a need. Okay, so that's more or less the general structure of the API. Again, you are invited to look more into it. Just a few points about FastAPI. FastAPI is very cool. I like it a lot. It's fast. It uses a modern web HTTP2 facilities. It is friends with streaming, with WebSockets. It reduces boilerplate when writing the API a lot. And today, as we mentioned already, we are using database for caching to skip running the same computation, the same prediction on the same input twice. A cool thing of FastAPI is that as soon as you run the API, Swagger UI conformant to the OpenAPI specification is started for you for free, and you will see it later. So I'm not saying much more on that. Well, there are a few highlights on how this code is structured. There is more for you if you're curious on the README, but let me just mention that FastAPI supports streaming responses. So the HTTP encoding chunked when you have a long streaming incoming stream of the response and you want to send it out chunk by chunk to the caller. And this is done, you see now in the code block. You can look at it in the code. And of course, besides post with body validation, we also can support get endpoints with query string. But I think this is more or less something you will look at later if you're interested. Now I think the big important point is for you to actually run the API and see it in action. So running the API, running it through the Swagger UI, and if we have time, maybe a quick look at what happens on the database, but I'm not sure. With that, Artyom, back to you again.
Okay, thank you. So going back to our project, under API, we have the core, all those files, scripts that Stefan explained how they interact. For example, this is your black box AI model here, which is just basically a wrapper around what we had here with working with generating this model. But now this wrapper is going to return some JSON rather than just text like here, and here your database access functions, such as storing and reading, and this is the main one, which actually exposes the API using FastAPI. So here's your application defined here with some metadata and some startup instructions, but this is the first API here, which we will be using shortly. We will run this API. We'll see what the output. Basically, this one will give some metadata output. This is another one for prediction. This is another one for predictions, and so on, so on. And you will see those endpoints, how we will be able to use them. So this is where to find this information. Now, to run this project using web server, we still need to specify, we still need to add credentials to connect to the database. So going back to our instructions, expose an API, the first thing we will need to create environment file with all the variables that we need. And for that, the first thing I will, for that we will use ASTRA CLI. So we will set up ASTRA CLI. So let's go back to our project, and we will start ASTRA setup. So this is the command line interface, the utility that can connect to the database in the cloud, but it needs the token. Remember, we generated the token previously, and I will show how to do it again, and we'll use that token. So I need to copy paste this token here. If you saved it somewhere after you generate it, you can copy paste from there. In my case, I'm gonna just show you again what I can do to generate the token. So this is my database, workshops. I will generate a token for role database administrator, generate token. Okay. And this is the last line here. I will copy, and at this point, I can go back to the project and paste my token as input to ASTRA CLI. So ASTRA CLI says that everything is okay. We are able to work with the database. Okay. So let's see what other instructions. Okay, so we can get information about our workshops, again, using CLI. Let's get information about the database itself. You can see the ID of the database, name, it's active, it's running in GCP, US East 1 region, it has key space, a spam classifier that we created, no other key spaces, no other regions. You can, by the way, create database in multiple regions, but that's not with free account. Okay. So the next thing, we are going to create this .environment file with useful variables for application to connect to the database. Okay, so what happens here? We downloaded so-called secure Connect bundle. Okay, let me see. Don't see it here. Okay, so what happened? We created this .env file with all the important variables here that I will need to destroy later. And we also will need to add some additional variables specific to our application, specific to machine learning, right? So I will, okay. So they were added here as additional classifier parameters. Okay. So at this point, I should be able to start. So there are two sections here. One with minimal API, which is you only you never used FastAPI before. Maybe you can try this one to just see, just get a feeling how it works, how the API defined. But I will skip it to save time, and we will just go with the standard API, which has more functionality. Okay, that's minimal, and this is the full API. Okay, let me start it. Okay, so we have a web server running our API, and we want to be able now to see if we can access that API and get some response. So this is the curl command, which will basically send HTTP request to this URL. So let's go to the curl shell, and here we go. All right, so this API is essentially the path is just slash, and we respond. The response is just some metadata. Okay, what else can we do? Can we classify a message? Here's the message: click to win a free car. Okay. And this is how the output looks like. So this is JSON, more application friendly, and it has the prediction, and it even selects which one is the top, which one has the higher confidence, right? So with 87% confidence, this is a spam message. Okay, and what else can we see? Did we get the answer from cache? Did we get it from database? And the answer is not. Let's actually run it second time and see if we can, if this is changes. And you can see that it changed to true. So this time the response came from the database, from our cache. So it didn't run the model the second time. And we can experiment even more with another client. Instead of using Perl, we can use Swagger UI. For that, we will, so Swagger UI basically comes with automatically with FastAPI, it's underdogs, but we need the correct proper URL to open it. So I'm gonna run this command to find that proper URL, and it will be different for each project. For you, it will be different because you have a different Gitpod instance. So I'm gonna copy, and I will open it in the in this new tab, and this is what I have. So this is Swagger. Essentially, I can use these endpoints. I can try them. This client will now submit HTTP get and post requests. We have one get, two posts here. For the classification part, we'll submit to the server, and the server will use our model. So just for to save the time, I will copy some. So here we have for multiple text, multiple predictions. Let's see how it works. Okay, going back to Swagger on the prediction. So this one accepts multiple text predictions. Click on try it out, and this is sample text here, sample body, request body. I will replace it with a new one, and just click execute. Okay, so the response code 200, so it worked just fine, and we can see that the first message was ham, the second message was ham as well. Because there is no spam there, right? This is the proper text there, and you can see also that we didn't serve failures from cache, false and false. Let me execute again. And now we're serving the result from the database, right, from cache. So I don't know if we can measure it easily here, but it feels much faster when we just serve it from database and then we run in the model. Okay, we can try again, another one, which this one, for example. Okay, this one. So let's replace the text. So here we will be able to use two of them from the database and one from cache, and one we have to run the prediction. And you saw maybe it took a little bit of time. So cache, and then new prediction. Execute again. Seems like much faster. Okay. The only other thing that we can take a look is how we actually store this cache in the database itself. So let me close. Let me go back to. So there are different ways how you can do that. You can use again ASTRA CLI. I'm going to show you instead here. So we can select workshops and click on CQL console. CQL is Cassandra Query Language. Okay. And we can use our key space spam classifier, and we can select everything from spam underscore. We have two tables. One of them is cache. So let's see the cache one. Select everything from this table. Okay, and you can see we have those tags that we just tested were cached here and in this table. Okay. And I think we are running out of time, so that would be it for the exercise part. There is a little bit more to do in the exercise if you want to do it later as a homework.
Okay, yes. So I'll switch back to me. Thank you, Artyom. In the meantime, there have been a few questions in the chat. Unfortunately, a couple of you somehow got lost in the process, maybe because of some glitch in Gitpod. Someone also maybe found it hard to navigate the Astra UI. I'm very sorry, but we are almost out of time. So please join us on Discord. We will be able to help you and to provide further assistance, or maybe just by watching the recording again, you will find the solution to your problem. But we are always here to help you. But now you will excuse us, we go forward. Oh, that's an important question. Okay, great, Serge. Sorry about that, but please reach out. We are always there to help. deadline to do the exercises. No strict deadline. If you do that within 1 week, maybe it's best. Otherwise, we will periodically grade new homework submissions, so no problem. Okay, so you have seen the model running as within the API, being offered as endpoint. You have tested the interaction with the cache. Thank you, Artyom. You did great in showing everything in actually a little time, very clear, including reading the DB, which is great. I hope that is somehow has been convincing to you. Of course, this is not the end of it, because you might be interested in how to actually put this API on a server with, I don't know, Nginx and everything running in actual production setup, how to handle actual model versioning and having several versions of the model running on the same API with different prefix, how to tackle, let's say, introducing real-time data input to this architecture, how to put a feature store in the middle of this all. Well, this is, of course, a big direction for, actually, this is many directions to investigate, but luckily we cover you. And if you look at the end of the repo, there are 2 appendices which give you further interesting points to start from. They link to a different repo where the versioning issue and the feature store issue is explored more in detail. And there is a lot more, but today I hope we gave you enough to get you started. Which brings me to concluding. So let's do finally the quiz. So I fixed my issues with Mentimeter, and we can finally run the quiz. So I would like you to join, if you didn't do already, to join us on Menti. And okay, so maybe Artyom, I move you around a bit for the time being. You can go to menti.com and enter the code you see here, or you can use the QR code, or there is also the link in the YouTube chat. Yes. So please join us, and there will be a few questions. Quiz. There will be a few questions. Thank you, Marius. We are glad to hear that from you. There will be a few questions. This time you have to be fast in answering, and answering in the correct way, and you will get a chance to win some prizes. So maybe we wait. Okay, so I think we can start. So there are 6 questions, and please look at your phone, don't look at YouTube, and we start. Today, we saw an example of image recognition AI, supervised learning, random forest, unsupervised learning, or a ballet by Tchaikovsky. What did we do today? Supervised learning, well done. So we provide a label set, and we ask the network to get as close as possible to the example classifications we provide. Well done, and let's see how the leaderboard is. Okay, so Johanna, Serge, and Annikit on top, but of course this is just the start. So let's move to the next question. Question number 2, answer fast to get more points. The text classifier model, look at your phone, or is trained within the API code, or is a feed-forward neural network, a lasagna. Maybe it needs no training. It is designed to have some kind of memory, or I cannot tell you because it's classified. What is your answer? So you remember some delicious dishes in the okay, it is designed to have memory thanks to this LSTM unit cell containing memory. It's not a feed forward because it has these feedback loops of the signal going through the network, and it's not trained within the API code. The API code just takes it trained and just applies it to new text all the time, because training is one step and then we expose it as API. Okay, so let's see what happens to the leaderboard. Are there any big changes? Oh, Aniket probably will jump. Oh, Emma and Marius jump to first and second position. Wow, big changes. Let's go. Question number 3. Answer fast and answer correct, and you will get more points. So, to train the model, we call the train method, or we call the fit method, or we call the optimize method, or we call the predict method. We set the properties of the model, xtrain, xtest, or we have to write the full training algorithm ourselves. Well, I can tell you that I once wrote from scratch as an exercise the full training code, and it's long. It's a mess. Okay, correct. We call the fit method. We don't have to write the code itself. It's ready-made in the libraries. We call the fit method. That means training. And wow, there are a lot of changes in the leaderboard today. So Aniket jumps again to first position, Dr. Centipede and Casey, and then Filippo, Emma, a lot. So it's all still, everything can happen with question number 4. Answer fast and try to recall what we saw. So we use a database, that's undisputable, but we use a database called Keras. We don't use a database. It is called ASTRA. It acts as a middle layer between the API and the classifier, or it is built on Cassandra. So I think there might be at least one right answer, and there are 2 correct answers. Everyone got it right. It's called ASTRA and it's built on Apache Cassandra. So well done. And the leaderboard has again some changes. Well, not so many, but Aniket maintains first position. Okay, so question number 5. 2 more to go. Using Cassandra driver's object mapper, you remember, you can forget about the table structure at all. There is not even a table involved. You still must choose a proper data model, or it is an alternative to the NLP classifier. So we use object mapper instead of the classifier. I don't know if that last answer makes much sense. 7 of you got it right. I hope Artyom is happy. You made Artyom happy because yes, you can use the object mapper all you want, but do not forget that Cassandra will work best, will work at all only if you are respectful of choosing the proper data model. Otherwise, you run into problems, performance problems probably. So again, some changes in, wow, this is a very surprising leaderboard every time. So Aniket, Dr. Centipede and Serge are now in the first 3 positions, and we are to the last question. Fingers ready, go. Answer fast. What are the notable features of FastAPI? We mentioned a few of them. Streaming responses, request body validation. You can script it in COBOL. It has support for OpenAPI docs, or it has native support for Golden Dolphin. Let's see. There is more than a correct answer here. Time's up. Good. No one got it wrong. Very good. Streaming, request body validation, and support for OpenAPI. You saw all that in the slides and in the practice, so great that you paid attention. Let's see the final leaderboard. Seems like, whoa. Okay, so Aniket won, Dr. Centipede and Serge second and third, and I congratulate all of you. Well, all of you really for having participated, for staying with us until now. Of course, the real prize is not the swag, it is the knowledge, but a little swag does not hurt, right? So if you are Aniket, Dr. Centipede or Serge, please take a screenshot of your winning screen. A screenshot of your screen, not of this YouTube live. So the one that proves that you are the winner. the first 3 positions. Take a screenshot, make sure you take a screenshot now, and I will move, if I manage to, I will move back to my slides. So take a screenshot, as I was saying, if you are in the first 3 positions, and then go to this form. I will have these into the chat as well. So there is a Google form to fill with your just your email and your screenshot. We will then reach out to you and give you instructions to claim your swag delivered to you wherever in the world you are. Okay, so we are almost done for today. I would like to invite you again to our Discord server. Sorry, I have a bit of a voice issue at the moment, but 2 hours is long, right? So I invite you again to our Discord server where we can chat and discuss and help you and whatnot. So please join us. And yes, I think we are almost done. Please remember to subscribe to our channel. And before closing, I hope you got the time to take a screenshot of your winning screen, because I want to, if I manage to, I want to move. Yes, I would like to collect some feedback from you for how to make these workshops better. If you have anything to suggest, we will leave this running for a little while, so please let us know, honestly. And I think with that, we are almost done. So maybe I will drop still one more link in the chat. If you want to get up to date to other workshops that we will be running, we run a workshop per week usually, and on several topics. So please take a look at the workshops link I gave you, so you might be interested in other topics in the future. See you next time then. Remember, there is a homework to do. I was almost forgetting. If you scroll down to, maybe I will also give you a link here. Homework. If you scroll down in the repo, there are instructions on how to do the homework. That involves a little bit of coding and to tweaking something in the API and showing us proof. You get to, there is a form to fill with your homework submission, and there are a few theory questions. In a few days, we will review your homework and give you a nice badge. You see this last one, AI as an API. This is one of many collectible badges, verified badges that we issue, and you can then use them to brag about on your social, to share them and to feel better about yourself. And every workshop we do has an associated badge, so collect them all, as they say. And with that, probably we are just there to say thank you and see you next time.
Thank you. It was a pleasure having you.
I will switch back to some music to close and relax. And yeah, so bye-bye, everyone.
Bye-bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
A being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.